Good morning, everyone. So, I'm really sorry. Just give me 1 second. Yeah. Uh, Today we are going to focus on linked list, and I'm going to be implementing it in Python. I have couple of methods that I want to do. So initially, I will be implementing the node class, which has these default methods because, as we know, in linked list, it is built. A linked list is using built using nodes. Then I will actually let me just take out the remove node from here, because at the end of the day, without a pointer I cannot remove a node. So I'll take it from here and I'll put it in here. Perfect. Also, I'm using an app called Superlist, so this is actually really cool because it will allow me to create as many extensible lists as I want from here. So that's why. Right. So let's start with the node class. So let me just do code. Yeah, this is exactly what I want. So this is just an empty directory. As you can see, I have nothing in here. It's just on desktop. So I'm just going to create code linked list.py. So this is going to be our Python file, and yeah, when this code is done, I will upload it to my GitHub. You can find it in my repository. I'll probably create a repository called YT code or something, and I'll put this one over there, and I'll share the link in the description as well anyway. So perfect. So let's start with the linked list. Okay, so sorry, let's start with the node class. So let's define class node, which takes our init method, and obviously it needs a value as well as a next node, or we can call it a link node. I generally call it link node. You can call it next node, or you can just call it next. It's up to you. Right. Now I'm gonna assign our self dot value to value and self dot link node to our link node. Perfect. So with the init being done, now I have to create a getter for the get link node. So let's do that. Getter for value. So def get value, which takes a reference to the self, and we will return our value. Perfect. And after this, let's define a getter for link node, which is also a def link node self sorry, return self dot link node. Perfect. So with these two being done, we just have to define the set link node method. So let's define setter for link node, where we just give it a value. So set link node, sorry, we give it a node. This could be our next node, and we will say self dot link node. For a node, when we want to set a next node, we just call this function, and here we pass the next node. So that would be this next node. Perfect. So this is our node class. Pretty simple, pretty basic, nothing fancy, but it gets our job done. Also in this class, this is a basic link node, so I'll just put it here. It's a basic basic node, because the value is immutable and the value is declared during initialization, I guess. So that's the code. So every time I define this node, I have to give the value immediately, because it is not a nullable value, or it doesn't have any default value assigned to this. Okay. In fact, there might be complicated nodes, but I don't think you don't usually encounter that kind of complexity, especially in the interviews, because they are time constrained. So next, now that node class is done, because we finished everything, so let's go to our linked list class. So in linked list 2 I have to define the init function. So let's define class linked list, and let's define our init function, where I'll give a value, and here the default value can be none. So let me just give the value, and let's define this as a node. So node is node of value, and then, or I can even call it head node at the end of the day. Actually, let me just call it head node, and then I'll say self dot head node. So since this is going to be the first node, when we initialize it, obviously that's going to be the first node, is the head node that we have defined here. Great. Alright, so with the initialization function done, with the init function done, let's look at our next function, which is to get the head node, which is a very simple function. We just have to write in the head node. Okay, so guys, sorry, just give me 1 second. Okay guys, I'm back, sorry about that. Right, now let's define our next function, which is to get the head node. So I'll write get head node, which obviously takes just the self reference, because we are just returning our head node. So this is actually called peaking, where we see, technically it's not called peaking because peaking comes in stack, but let's say if you just want the head node, we are just gonna return the head node. Great. So in fact, let me put a comment here, getter for head node. Great, so that's done. And now let's go to the next function, which is to insert at beginning. So how would insert at beginning would happen? So the idea is that I wish I had some tool to draw it, but let me put it in a crude way. So let's say I already have, let's say I have B goes to C. This is the existing linked list, right? So B is the head node, right now B is the head node. We agree that. Now if I want to put a new node called A, okay, so all I would have to do is I can write something like a dot link node, or set link node equals to B, and then make our head node equals to A. So that's the strategy in order to insert at the beginning. So let's do that. Okay, so here, sorry, let's go to here. Now I'll say def insert at beginning, and instead of taking a node, we can directly take a value, because we can convert that into a node. So I'll just take a value, self dot value, and I'll say I'll just call it new node, I guess. New node equals to node of value. All right, and let's get the current head node. So current head node equals to self dot get head node, right? So we got the current head node. Now I'll say new node dot set link node, which is the next node, to current head node, right? We did that, and then finally, okay, so this is done. A link node equals to B is done. Now I just have to set the head node to A, which is head node, which is self dot head node equals to new node. Perfect. So if we want, we can even test it right now. So let's see, let's run this program and test it. So let's say I create a linked list here. So let me just call initially, let's say I am giving C is equals to linked list of 34, I guess. And now I can say C dot insert at beginning, and I am inserting 23. So now 23 has to be the head node and 34 has to be the next node. And then I have C dot insert at beginning and 45. Oh yeah, also we have to print the list, because how else are we going to visualize it? So actually let's print the list after this. So now insert at beginning is done. So for now, if I want to print it, I could probably use a for loop, but that's what we are going to do here anyway. So let's see these methods. So insert at beginning is done. For now I'll just I'll implement stringify.list first, and then I'll do the insert at end. So let's do stringify. So print the entire list. So I could either use the arrows, or I can use the new keyword. Let's use arrows for now. Okay, let's use arrows for now. So let's say def stringify list, and it just takes our self, right? It doesn't take anything else. So in the stringify list, the goal is we have to make sure we have to make sure that the data is not equals to null, because if the data is null, there is no point in printing that string. So first I'll just call something called maybe our linked list string equals to an empty string, right? And first let's take our current head node. So I'll call it current head node equals to self dot get head node. And let's see, while current head node, now instead of calling it current head node, let me just call it current node, which makes sense. Okay, so while current node, alright guys, sorry, I just have to be back. Alright guys, sorry, I'm back. So yeah, we were doing insert at the beginning. Now we wanted to do stringify list. So let's actually do stringify list. So what is the idea? We define that initially a LLL string is empty, and then we are just getting the current node, right? And now we just want to ensure that when we write this thing, and also while I'm writing the code, I kind of realized something. I realized that if the value is none, there is no point in setting the address of the head node. So what I'm going to do is here I'll say if value is none, right? Now if the value is none, what we'll do is we'll write self dot head node is also equals to none. All right, and if that's not the scenario, then within the else we'll just do these two. Okay, so within the else we'll set the node value and the head node. Okay, now that we have the okay, now I got the first node. So what we will check is while current node, all right, if current node dot value, because we are concerned about the value, is, or in fact I think we can even go with the next node, like the link node, because if that is null, then we just print this value. That's it, right? Get link node is not none. Okay, so if it's not none, then we just want to print lstr plus equals to get value. Oh, but that is a question, because in the last one, for the last one, the data would be none, right? Can't we just do current node is not none, instead of like next node? So I'll just do if current node is doesn't have to be a function. If it is not none, just keep getting the value, and after we do that, okay, after we do that, let's do current node equals to current node dot get linked node. Perfect. And after the entire while loop is done, let's add lstr plus equals to none. We just want to show that after that there is nothing else. Oh, and yeah, while we are adding it, this is generally an integer, so I'll convert this to string. And after each string we want to add this symbol, so plus, oh sorry, there you go. So I add the symbol. Let me just make this bigger. Let's do left 2/3, and this could be, yeah, this could be anything. Okay, all right. So with this done, and after we added this, we can just return the list here. So in fact, if you want to check right now, I think we can do the check, because we do have the default methods. So let's do a couple of things. Okay, so first test one is, okay, linked list with no value, right? Linked list with no data, and I want to print it. So I'll say ll no value equals to just linked list, and I'm not giving it any data, because I can by default we set that the data could be null, right? So that's one. And let's go for the right. So we have the linked list with no value. Now I want to see what kind of data is in here, so let's print ll no value, then stringify list, and let's run it. So I'll do python 3 linked list.py, and as you can see, it says none, because the linked list is empty. Or I could probably do like I can even check if it is empty or something, like print empty list or something, just to be sure, but it's up to us. So the way I do it is, I mean, like, this is the general idea. Like, the way it will get is, like, say if I have 5 4 2, so I'll have 5 followed by 4 followed by 2, I guess, and finally it will say none, because after 2 there is nothing. And if there is no string, this one, I'll just say prints none. Okay, so this is the general idea. Okay, I'll say general format, my bad, sorry, general format. So now that the stringify list is done, next to, okay, so string, oh yeah, so this, we just checked it with no data, but let's check it with some data. So let's say I'll say linked list, I'll just call it ll. Okay, I'll just call it ll1 just for sure. Okay, so a linked list, initially let's say the data is 2. Okay, now I'm gonna insert one more at the beginning. I don't have one at the end, unfortunately, so I'll say ll1 dot insert at beginning, let's do 4, followed by ll1 insert at beginning 5. Great. So initially the data was 2, but like a stack I put 4 on top of it, then on top of 5. And as you probably know, because we are going to cover stacks in future in this series as well, but if you want to implement a stack using a linked list, what you do is you just define the insert at beginning method, so there would be no insert at end method. You probably call it push or something, but we are not we don't have an insert at end, because stacks follow LIFO structure, last in first out, right? But let's see, now let's go ahead and print this. So I'll say ll1 dot stringify list, and let's write the output. So the output is supposed to be 5 followed by 4. I mean, there's not going to be a space, I think, but if I want, we can probably give some space, so I'll just give some space. Yeah, 2, and before that 2. I mean, it's up to us. Okay, so 5 4 2 followed by none, right? So let's go ahead and run this. So I have python 3 linklist.py, and there you go, it says 5 4 2 and none. Perfect. So excuse me, sorry. So the stringify list is working perfectly. Now let's write another function. So let's go to our super list, and let's write another function called insert at end. Great. And in fact, I'll just write it at here, so that I can have insertion functions at the same time. Okay, so sorry, at same place, insert at end, right? And now I'll say insert at end, it also takes self comma value. Now first of all, let's take the head node. Node is equals to self dot get head node, right? And initially we want to check if if it's empty at the end of the day. We just set it to the same node, right? And we probably have to do the check at the beginning as well. I mean, even here, if it is empty, it's just gonna point to none, so there's no problem here. Whereas here, what I'll do is I'll say if head node is none, right? Because the way we defined it is, if there is no data, the head node is gonna be none. Okay, so if head node is none, then we'll just say self dot head node is equals to node of value, right? So that's one. Or I can give this some values. So I'll say end node equals to node of value, so that I can just do end node here, right? So if head node is none, we are setting it to end node. But if it is not none, then what do we have to do? So else okay, or we can rename it to current node just to be sure. Current node, right? If current node is none, just set it to the head node, because initially it is at the beginning. Okay, so next what we want to check is while current node dot get linked node, so the next node is not none, right? Okay, if it is not none, just keep iterating through the list. So I'll write current node equals to current node dot get linked node. Perfect. And after that is done, we will finally say current node dot set linked node using our end node. So we can even test this. So let's test for end node. So that was test 1. This was test 2 with insert at beginning. Now let's try test 3 with insert at end. So I'll say ll2 is, let's say I just have a linked list of 1 and I'm just going to insert numbers at the end. So I have 2, insert at and 3, 4. Alright, and now let's try printing the list. Right, so ll2 dot insert at end. Sorry, not an insert at end, my bad. Stringify list. Right, and as we know, this is supposed to print 1 followed by 2 followed by 3, which finally gives to none. So let's run it and see. There you go, it says 1 2 3 4 followed by none. Perfect. So our insert at end is also working. So these two are working perfectly. So let's, alright, so let's go to the next function. So insert at beginning is done, insert at end is done. Now let's go to the next function, which would be what do we do? Yeah, okay, let's look at our super list. Yeah, now we have remove node. So remove node is is actually very important. So in remove node, the idea is if we have a to b followed by c, right, and if I want to remove b, what do? I directly do results equals to directly a to c. Why? Because the goal is at the end of the day, at the end of the day, I can just remove the pointer. Sorry, I can just change the pointer from a to c, and b will become an orphan node. But thanks to the garbage collection in Python, we don't have to worry about it, because Python takes care of all the garbage nodes. And I guess basically any modern operating system and modern programming languages do have garbage collectors built in, so we won't have to worry about them. So let's do remove node. So I have def remove node, I guess, or we can just call it remove mistake self. And I mean, it's up to us, like, do I want to directly take a node here, or do I want to take a value here? If I mean, for now we can take a value, because we can convert it to node anyway. So let's see, I'll say remove node equals to node of value. All right, now what do we want to check? We want to check if this node, I mean, how do we compare? Like, I guess we can just compare the values. So actually we don't even need to create a node. Okay, what we'll do, so what is the idea here? The idea is to basically iterate, and if we find it, get the link to the next one and just remove it, right? So what we'll do is, let's get the head node first. So current node equals to self dot head node, right? We got the head node. Then while current node is not none, right? Current node is not none. What we'll check is if current node is if current node dot get value get value double equals to our value. If that's the case, so what do you want to do? I'm just wondering if we have multiple scenarios for parent node as well as for other nodes, or could we just define it? Imagine if it's the hey guys, so sorry about that. The previous remove function wasn't working for some reason, so I'm just gonna rewrite it again. So I'll say def remove node, and which takes self comma value to remove. Right now what we'll do is, let's first of all get the current node. So we'll write current node equals to self dot get head node. Now the first thing that we want to check is if is the head node, right? If it's head node. So what we will do for that is, first we want to ensure that this is not null. So if current node and current node dot get value equals to value to remove, right? If that's the scenario, then we'll just do self dot head node equals to, we just want to set it to the next node of our head node, right? So current node dot get link node, and then we can just set our current node to none, right? Perfect. But if that's not the case, then let's write else, and we want to ensure that current node is never null, so we'll write while current node, right? Let's create our next node. So I'll write while current node, so let's write next node equals to current node dot get link node. Again, we also want to check if next node, right, and next node dot get value is equals to value to remove, right? If it is equals to value to remove, then what we will do is current node dot set link node, and within that we'll just set next node dot get link node. Okay, so if it is that, then we'll just do next node dot link node, and then we can set next node equals to none. And if it's not the case, then we'll just do next node equals to current node equals to next node, because it will just directly go to the next node. Perfect. So this should generally handle the issue, I think so, because this basically handles all the scenarios. So let's go ahead and test it out. So I have the test for where I'm removing the node. So initially I inserted 10, then I'm inserting another value 20, followed by 30, 40, and up to 60. I inserted from 10 to 40, and I'm just removing 30. So I should get 10, 20, followed by 40. So that should be the expected output, right? So the expected output should be 10, 20, followed by 40. And let's run it, right? So I have warp cd desktop, I think it was called yt code, yeah. And I'll write python 3 linklist.py, and there you go. We get 10 followed by 20 followed by 40 followed by none. Perfect. So remove node is done too. Great. So the entire linked list is done. Now we have to cover swap methods, but I will be doing that in the next video, so stay tuned guys. So I guess once I post the next video, I will you can find it on my channel, and as always you can find the source code for this for the entire linked list I've created on my GitHub repository. Okay, so I'll just create a GitHub repository and I'll put it in the video description. Alright, so thanks a lot for watching, and I'll see you guys in the next video.